Hello students, myself Professor Ankur. I welcome everyone for the GATE sum session on analog circuits. Today we are going to solve important sums from voltage regulator. This is our third sum session on voltage regulator. Let's start with the sum session now. So this question is from the GATE 2013 EC paper. Let's have a look at the question. The question is, in the circuitry shown below, the knee current of the ideal Zener diode is 10 milliampere. To maintain 5 volt across load RL, the minimum value of RL in ohms and minimum power rating of Zener diode in milliwatt respectively are. There are 4 options given: 125 125, 125 250, 250 125, and 250 250. So this is a diagram given to us, and in the diagram you can see that the input voltage is given as 10 volt and there is a resistance of 100 ohm. The Zener voltage is 5 volt and the load is basically unknown. So the load is defined as RL in ohms, and we are supposed to find the two parameters for the circuitry. The first parameter is the unknown value of the load resistance, and the second is the power rating of the Zener diode. So for this, the first thing we need to do here is we will find the value of input current. The resistance is 100 ohm with a top point at 10 volt and the bottom point at 5 volt holded by the Zener diode. So we can get the value of input current as 10 minus 5 by 100, which will be 50 milliampere. So this is the value of input current. So if the Zener takes 10 milliampere, then automatically the load will take 40 milliampere. So the IL value is In minus Iz. The value will come as 40 milliampere. So the value of RL will become VO by IL. So the value of VO is basically the voltage across Zener, that is 5 volt. So it is 5 volt by 40 milliampere. The value will come as 125 ohm. That's the value of RL. So out of the 4 options, option A and option B are left out. C and D will be rejected because A and B are having both the values same as 125 ohm. Now the final selection will depend on the rating of the Zener. So the power rating of the Zener will be Vz into In, because the maximum possible Zener current can be 50 milliampere in case the load is disconnected. So under this situation, the Zener will take its max value of current, which will be equal to 50 milliampere. So the input current will be equal to the Zener current that time. So the value of the power rating will become Vz into In. The value of Vz is 5 and the input current is having a value of 50 milliampere. So automatically the value will come as 5 into 50 will give me 250 milliwatt. So the value of your power rating for the Zener is 250 milliwatt. So if you observe carefully, option B gives you RL as 125 ohm and power rating as 250 milliwatt. Hence the correct answer for this question is option B. This is from the GATE 2011 Inch 2 paper. Let's have a look at the question. The question is, the output value VO of the series voltage regulator shown below is. So here this is a transistorized regulator circuitry where we are having op-amp as a comparator with a reference voltage of 6 volt connected to the non-inverting pin of the op-amp. The supply voltage is 40 volt DC and we are supposed to find the value of output voltage VO for the series regulator. So here the property of op-amp will come into picture. The non-inverting voltage will be equal to the inverting voltage. So V plus will be equal to the V minus. Since V plus is at 6 volt, the V minus value will be also at 6 volt. So 6 volt will now come across 2 kilo ohm resistor. So now this voltage is basically a part of the voltage divider circuitry where VO is the main voltage. The first resistance is 8 kilo ohm. The second resistance is 2 kilo ohm. And we know the voltage drop across the 2 kilo ohm resistor, that is 6 volt. So using the concept of voltage divider, the V minus win voltage will be VO into R2 divided by R1 plus R2. So the V minus will be put as 6 volt and the value of R2 as 2K, R1 as 8K. Solving, you will get the value of VO as 30 volt. So the correct answer for this question is option C, 30 volts. This is from the GATE 2007 EC paper. Let's have a look at the question. The question is, for the Zener diode shown in the figure, the Zener voltage at knee is 7 volt, the knee current is negligible, and the Zener dynamic resistance is 10 ohm. If the input voltage Vi ranges from 10 volt to 16 volt, the value of output voltage VO ranges from. So here we need to understand that there is a supply which is going to be a fluctuating supply with a lower value of 10 and an upper value of 16. The Zener is having a knee voltage of 7 volt and we are supposed to find the value of output voltage VO. The internal resistance of the Zener, which is the dynamic resistance RZ, is now given as 10 ohm. If input is 10 volt, then the value of current I flowing in the loop will be 10 minus 7 divided by 200 plus RZ. So the value of current I will become 14.8257 milliampere. In this case, the value of output voltage will become I into RZ plus VZ, where VZ is already 7 volt. So I, which is 14.857 milli into 10, and then adding VZ to it will give you 7.14 volt. So if the input is 16 volt, then the value of I will become 10 minus 16 minus 7 divided by 200 plus 10. So the value comes as 42.857 milliampere. Again, you can get the value of VO as I into RZ plus VZ. This will come as 7.4289 volt. So if you observe the options carefully, you can see 7.14 volt as one value and 7.43 volt as the other value. So the correct answer is option C, which is 7.14 volt and 7.43 volt.